So, having said that, one of the things we totally glossed over last time was the issue of the modeling process. Excuse me. Let me go back to that. I mean, how we actually arrived at these models. It's all well and good to go look at a model like this. Say, okay, this represents some situation. Or to go look at a model like this and to say, well, this represents some situation. But it glosses over a lot of issues. So how do we go about from some understanding of a situation to actually capture it in this sort of form? How do we know what to put in, what to put out? Because after all, if we're modeling persons, we've captured some information, but we've left out a heck of a lot of information. How do we know what to put in, what to leave out? How do we think about that process? How do we know that this is a reasonable representation? That at least, even if we're not sure it's right, that at least it's plausible? How can we test it in some ways? To test its reasonability. And given that we want to build up a model like this, how can we build it up in stages to first sketch what we want and then capture it in a really quantitative way that allows us to run it? Last time we saw some models that weren't runnable. Can anyone give me an example of the sort of model we saw in our last class that was not runnable? I argued it was a model, but it was not a simulatable model per se. Sorry? Yeah, so I had a model up here which involved addiction, I think. You remember that? We had a cycle of addiction and so on. So that's an example of a model that's more qualitative. It actually has some, as we'll see, there's some quantitative elements. It's a permanent part of system dynamics, and you can reason about some of its dynamics just from that alone, but you can't simulate it. You know, one time I was working with someone who really wanted me to simulate a model like that. He had a great ongoing thing. He said, can't you just run it? And the problem is the specification is so imprecise. You know, there'd be a huge number of possible behaviors. You couldn't simulate it. It's not specific enough. It's not precise enough to allow for direct simulation. But it's useful for sort of capturing our understanding, for reasoning, sometimes for highlighting opportunities for intervening. But then at some point you can go from that to a quantitative model, a model that can be simulated. It yields very precise results. Now that doesn't mean deterministic always. Sometimes it can have stochastics, variability, even while it's running. Sometimes the vagaries of who infects who will be different. If we ran this model several times, and as long as we had different so-called random seeds associated with it, I think for this one, for the default experiment here, it was a fixed seed. In other words, it's running the exact same sequence every time. Every time we run it, it's like that movie Groundhog Day. It's the same thing every time. Boom, boom, boom. Well, okay, he made it so it's not quite the same in the movie, but it's the same thing every day. But for the ones we defined, we actually had a so-called random seed, so it's unique. So every time we run it, it'll start in a different place, somewhat different place. And exactly who infects who and how soon someone gets infected is variable. But it's still precise in the sense that there's an exact specification of the semantics of the model and the probabilities of someone getting infected, etc. So if we have a precise model, we can simulate it. How do we get that sort of specification? And we'll look at that a step to do that. So a lot of issues that come into play here, and I'd like to talk about some aspects of it. I asked you to watch a video. Can anyone tell me from the video, what are some stages of the modeling process? What's a stage of the modeling process? Give me an example. Okay, data collection. Yeah, so that's a very important step that occurs for many models to ground them, to tie them into some, so they're describing some particular situation. Now I'm gonna actually mention. Well, let me put it out there to the group. Is data collection a central step for all models? The answer is no. There's many. There are some models out there where the model serves as more of a caricature. By a caricature, I mean it's not trying to represent a very specific situation, but it's trying to, it's aiming at providing some key insight, okay? An insight that transcends any one context, but is a general pattern. So many of you folks have your computers here. So we could call up such a model right now. I'd like to do that. This is one of the things we could, that we have the luxury of doing. So I'd like to go to AnyLogic here, and I'd actually like to go to Help, and you can go to Example Models, okay? And we're going to open a model called the Schelling Segregation model, okay? Let me see, is it, yeah, here it is. It's just in the examples provided here on the right-hand side. So how did I get there? I did Help Example Models, and these examples should come up. If you don't see them, you can click on Examples here. And we're going to go take a look at a model called Schelling Segregation, okay? So we're going to click on that, and it's going to open it. And now it's loaded it in down at the bottom here, okay? Okay, so within the Schelling segregation model, we again going to have a main space and a person space, okay? And the person space is going to have a variable saying are they satisfied with where they live or not. They also have a color associated with them. And this was meant specifically to kind of mimic situations where people from different backgrounds, and unfortunately in the U.S., it was created by a U.S. sociologist, I believe, who studied the emergence of segregation among different races. So the idea here is we have a situation where people live in a certain place, and people have two colors. They're either red or they're black, okay? And then there's some people, some spaces. And each person lives in a particular place, and there's some small fraction of places that are not occupied, these sort of yellow ones around the periphery, okay? And each person within this model moves around, can move around according to some rules. And if you go look at person here, within the context of person, there's going to be some rules by which they move. They move under certain criteria, and this is actually going to move in a step-by-step fashion according to some rules specified under person, agent, on before step, and on active step. And the basic gist of it is, if they're not satisfied with a 30% chance each time they're going to move, they're going to jump to some empty cell. Now their satisfaction is going to depend on the number of people around them, the composition of people around them. Are they the same color or not? Okay, so that will indicate kind of whether or not they're satisfied with their context. This is not in any way to justify it, but to kind of examine the effect of having some measure of color preference. Now, if the level of if you want to have, say, 50% people with your same color, if we have people being very closely matched as to sort of, they don't have any strong preferences to the color, and we're going to try to adjust this up here. There's 51% and there's 49. Trying to do it at exactly 50. Well, no one's going to change. They're actually in a very disordered state in the first place there. Okay, here we go. We have no one. Then I'm going to set it right in the center. There it is, 51%. This is a situation where with even 51%, yes, they'd like to have, they have a slight preference, a 1% extra preference for having someone around them that's their same color as not. Okay? A slight preference. You can still see some patterns around them, indicating there's grouping. But let's be clear about this. One of the things is, if less than 50% around them are the same color, they're likely to move. If more than 50% of the people around them are the same color, they're not going to be likely to move. They're going to be satisfied. So here, the point of this model is not to describe segregation in New York or Chicago or Detroit or something like that, although the creator of it was interested in it. The point is to kind of make this point that these patterns of segregation can emerge with even very, very slight preferences on the part of people. Slight preference for people who are the same color can lead to kind of macro patterns that are still segregated. You even see some of it with this sort of situation. If people are very likely to move, if fewer than 20% of the people around them are the same color, you could still see some kind of grouping. It's not totally random, but the larger it is, the more striking the patterns. And again, at even 50, low 50s, it can be quite large patterns of segregation. And at some point, they have a hard time finding any satisfaction. So here's 73%, for example. Here's 75%. And you can see very, very large patterns. Here, the goal communicated an essential truth. That even slight preferences can cause notable patterns in terms of segregation to emerge. These patterns, I want to emphasize, are these programmed into the model? Do you see this pattern coded into here? Create a block that, based on the sliders of a certain size. No, you don't. It just emerges out of the fact that people move if they're not satisfied, and satisfaction depends on the fraction of people around them that are the same color and their criteria. So this is a model that's a thought piece model. It's a model for insight. It's a model that's meant to illustrate some underlying truth about how these patterns can emerge even with slight preferences, but it's not meant to be data rich. So this is a model where data collection is kind of a modest component of it. You'll see other models this semester where data collection is front and center, because we're trying to model TB and its spread in Saskatchewan, or we're trying to model how chronic wasting disease is spreading within deer within Saskatchewan, or we're trying to model diabetes in Saskatchewan. And those models are really, really data rich, because we're trying to ask, how would things that change that impact things? What's the relative trade-off of different ways of trying to tackle those problems? And we want an answer that's quantitative. Here, the insight is substantial, but it doesn't require a lot of data to gather it. So this sort of model is a caricature. Some of you may have seen cartoons before, like in the paper, like a cartoon of a political figure, with someone who has a big, a giant chin sticking out. They'll show someone, and he has a nose and a giant chin sticking out, and they want to put it so that it's recognizable that it's a certain person. Sorry, I'm not an artist. This looks quite horrible. It could be a silhouette of Abraham Lincoln, but here's a sort of chin. Gosh, sorry, that's. But that might represent someone who has a large chin, or they'll make something to have his cheekbones be really high in a way that reminds you of someone, or what have you. So it's a caricature. It's not meant to represent all the details of the person, but really to communicate some essential truth. Okay, so data collection is a step. What's another step of modeling?